Imagine waking up one morning to a world transformed. The familiar blue sky overhead has faded to a cold, impenetrable blackness. The stars, once twinkling beacons of distant suns, are dimmer than you remember. Some have vanished altogether. The moon, companion to countless generations of dreamers and explorers, is missing from the night. And as you step outside, the ground beneath your feet trembles, as if the very earth itself is unsettled by something lurking unseen. This is not the beginning of a science fiction novel, but the hypothetical scenario that unfolds if our planet were to encounter one of the universe's most enigmatic and terrifying phenomena, a black hole. At the very core of our Milky Way galaxy, over 25,000 light-years from where you stand, lies a cosmic monster, invisible and insatiable. Sagittarius A, a supermassive black hole, millions of times the mass of our sun. It is an object so powerful that nothing, not even light, can escape its grasp. But what would happen if Earth, against all odds, were to be drawn towards such a black hole? To answer that question, let's unravel the mystery of black holes themselves. Contrary to popular imagination, a black hole is not an object in the traditional sense. It is a region of space where gravity has become overwhelmingly strong, overwhelming all other forces and warping the fabric of space and time itself. When a massive star reaches the end of its life, it can explode in a supernova, leaving behind a dense core. If this core is heavy enough, it collapses into a single point, a singularity, where the laws of physics as we know them no longer apply. Around this point, gravity is so extreme that it creates a boundary, the event horizon. Anything that crosses this invisible line or lost forever to the universe. To visualize this, imagine space-time as a vast, elastic sheet. Place a bowling ball on the sheet. This represents a star creating a dimple in the fabric. Now imagine that bowling ball suddenly becomes infinitely heavy and collapses into a pinpoint. The dimple deepens into a bottomless well. That is the black hole, a pit so steep nothing can climb out. So if Earth were to be caught in the gravitational pull of a black hole, what would unfold? The first signs would be subtle, at least from the perspective of those who dwell on the planet. The familiar order of the heavens would begin to break down. Light from distant stars and galaxies would appear distorted, stretched and twisted by the immense gravity. This is known as gravitational lensing, a phenomenon that causes the images of stars to swirl and arc into strange, ghostly patterns. The moon might fade, its reflected sunlight unable to reach us, lost to the curving path of light near the black hole. As the black hole's influence grows stronger, the effects on Earth become more dramatic. Gravity, which usually acts as a steady, predictable force, now becomes a wild, unpredictable presence. Our planet would begin to accelerate, pulled inexorably toward the event horizon. The familiar tug of gravity would intensify, and strange tides would sweep across continents and oceans. The closer we get, the more bizarre the effects. The gravitational field of a black hole is not uniform. It is far stronger at the side of Earth closest to the black hole than at the far side. This difference creates what physicists call tidal forces. At first, these tides might simply raise and lower the oceans, but as we approach the event horizon, the difference becomes catastrophic. Imagine standing at the edge of a cliff, looking down into an abyss from which nothing returns. Now imagine that abyss is the event horizon, a point of no return. As Earth crosses this threshold, the tidal forces become so extreme that the planet begins to stretch along the direction of the pull and compress in the perpendicular direction. This is the infamous process known as spaghettification. It's a name that sounds almost whimsical, but its reality is anything but. Continents would fracture, mountains would crumble, oceans would vaporize, their molecules torn apart by the ever-increasing gravity. Every structure, every atom, every living thing is drawn out into an impossibly long, thin thread, stretched beyond all recognition. For those unfortunate enough to witness this from a safe distance, the scene would be strange in another way. From the outside, as Earth approaches the event horizon, it would appear to slow down, becoming increasingly red-shifted and dim. Time itself, in the presence of such powerful gravity, becomes distorted. An observer would see the planet hovering, frozen at the brink of oblivion, never quite crossing over. This is because, near a black hole, time for a falling object slows down relative to the outside universe, an effect predicted by Einstein's theory of general relativity. For someone on Earth, the journey would last only moments, but for an outside observer, it could seem to take an eternity. And what of the experience inside the event horizon? Here, science meets its limits. The laws of physics, so reliable in our everyday world, break down under the extreme conditions near a singularity. All attempts to calculate what happens yield only infinities, quantities that defy logic and measurement. Some theories suggest that a black hole could be a gateway to another universe, or a bridge to a parallel reality. Others propose that information about everything that falls in is somehow stored on the surface of the event horizon, encoded in a way we do not yet understand. But these are only theories. No one knows for sure. What we do know is that once information or matter passes the event horizon, it cannot return. The fate of everything that has ever existed on Earth, every memory, every artifact, every trace of our civilization, would be to vanish from the universe, as if it had never been. The ultimate erasure, not only of physical form but of history itself. Could anything survive? Is there a way to escape, to resist the inexorable pull? The answer, as far as our current understanding goes, is no. The only hope is that such an encounter remains in the realm of imagination and not reality. But how likely is this scenario? Fortunately, the universe is vast, and even the most massive black holes are, on cosmic scales, relatively small targets. There are no known black holes anywhere near our solar system, certainly none close enough to pose a threat within millions of years. Sagittarius M, the supermassive black hole at the center of the Milky Way, is safely distant. Smaller stellar mass black holes do exist, but they too are far away. The odds of Earth being swallowed by a black hole are vanishingly small. Still, the mere existence of black holes challenges our understanding of the cosmos. They represent a frontier where science, philosophy, and imagination meet. Black holes force us to grapple with questions that have no easy answers. What happens to matter and energy inside? Is information truly lost? Or does it persist in some way we have yet to comprehend? Could a black hole be a tunnel to another dimension, or even a method of time travel? These mysteries fuel the relentless curiosity of scientists and dreamers alike. Powerful new telescopes, like the James Webb Space Telescope, are peering deeper into the universe than ever before, searching for the faint signals and subtle clues hidden in the darkness. In 2020, astronomers captured the first ever image of a black hole's shadow, a feat that required coordinating observatories all around the globe. It was a glimpse into the heart of the unknown, a photograph of the place where light itself is trapped forever. Black holes are not just cosmic vacuum cleaners, mindlessly devouring everything that comes too close. They are also engines of creation, in the swirling disks of gate and dust that spiral into them. New stars are born, and galaxies are shaped. The energy released by matter falling into a black hole can outshine entire galaxies, powering some of the brightest objects in the universe, quasars and active galactic nuclei. Without black holes, the universe we see today would be a very different place. But what do black holes mean for us here on Earth? They remind us of our place in the cosmos, small, vulnerable, yet capable of great wonder. They challenge us to look beyond the familiar, to seek answers to questions we can barely articulate. In the face of such overwhelming forces, our own struggles and achievements can seem insignificant. Yet it is precisely our curiosity, our drive to understand, that defines us as a species. When we gaze into the night sky, we are not just looking out at distant stars. We are peering into the past, seeing light that has traveled for millions, even billions, of years to reach us. We are witnesses to a universe that is vast, dynamic, and filled with mysteries. Black holes, with their paradoxes and enigmas, are the ultimate expression of the unknown. They invite us to explore, to question, to dream. The story of the universe is the greatest story ever told, not just of stars and galaxies, but of the minds that strive to comprehend them. In studying black holes, we are also studying ourselves. Our desire to know, to reach beyond the limits of what we can see and touch, is what propels science forward. Each discovery, each insight brings us closer to understanding not just the universe, but our place within it. If you find yourself captivated by these mysteries, you are not alone. Across the world, countless others share your curiosity, your hunger for knowledge. Together, we are embarking on a journey that has no end, a journey into the heart of the unknown. Each new discovery opens up more questions, more possibilities. The universe is not a finished story, but a living narrative unfolding with every observation, every experiment, every leap of imagination. So as you look up at the sky tonight, remember, the universe is not just out there. It is within us, in our questions, our dreams, our relentless pursuit of understanding. Black holes, with all their terror and beauty, are part of that story. They are not just places where things end, but where new ideas begin. They are reminders that, in the vastness of space and time, our own curiosity is the most powerful force of all. Let us continue to explore, to seek, to wonder. For in the search for answers, we discover not only the secrets of the cosmos, but the true nature of ourselves. Fragile, finite, yet infinitely curious. Thank you for joining in this journey of discovery. The universe is waiting.